Hello everybody, this is Mrs. Tree Fry coming to you with some information on how to use your calculator for statistics using scatter plots more specifically. So we're going to talk about scatter plots. You guys have been doing a few of them by hand, but funny thing is, it's a lot easier on your calculator. So talking about the line of best fit. A line of best fit is a straight line that shows the relationship between two sets of data the most accurate way you can. So then there's something that we haven't really talked about yet, which is the correlation coefficient. And the correlation coefficient is the number that tells how closely the data is related. It's usually called R when you see it in math, and it ranges from -1 to +1. So -1 is less than or equal to R, which is less than or equal to 1, which means that it's ranging between those two numbers. Because it's going to be a decimal, and it's a decimal because really it's looking at it as a percentage. So when you look at this page, I know it seems overwhelming at first, but we're going to go step by step through the information on your calculator and look at the buttons that you're going to use. But this is just here for you to always refer back to and understand step by step the process that it's going to take to use your calculator to do a scatter plot. The thing I want to draw your attention to is down here at the bottom. It doesn't say y equals mx plus b in the calculator for whatever reason. When the TI people put it together, they used a instead of m. So must be the algorithm couldn't produce the m the way they wanted to. I don't know. But y equals ax plus b. So A is your slope still, M, rise over run, B is your y-intercept, and R is your correlation coefficient. So you need to be aware of that. So going on to page 2. So the scatter plot is going to be a relationship between two groups of data, and a positive correlation. Both of the data sets are going to increase, which I'm sure makes sense to you guys after you've looked at some of these already. And with a negative correlation, one set of data increases while the other set of data decreases. So as one rises, the other one falls. With no correlation, which means that there's not a good, strong relationship going on there, you're going to have sets of data that are completely random. And a trend line is going to show the correlation more efficiently. So we're going to use this example 1 in order to put our data into our calculator. So the information says the table shows data students collected on their test scores and the number of hours they watched TV the previous day. Make a scatter plot on the data. So we are going to use our calculators. So we need to turn them on. We are going to need to go right here to list. And when you go to list, you want to make sure it says L1 and L2. So list 1, list 2. So the one here, this hours watched, is going to be our L1, or input value, and the test scores are going to be our output value. So that's going to go into list 2. So hours watched, we're going to type it in, 0, 0, point, whoops, not negative, 0.5, 1, 1, 1, 1.5, 2. Don't forget these over here. 2, 2.5, 2.5, 3, 3.5, 4, 4.5, and 5. I type in data a lot in calculator, so I might be faster than you, so go ahead and pause if you need to. But I'm going to move on. Test scores. So this will be list 2. So we go 92, 100, 89. I guess I don't need to read them to you. You can do that yourself. Don't forget these. And make sure everything's lining up, because if the 2 has to go with the 80, the two pieces of data are correlated. They need to go together. You need to make sure you keep them together. Very important that they match up. Sometimes at the bottom you skip something and these won't be lined up, and when they're not lined up, you're going to have an issue and you're going to have errors that will occur. So make sure that they are lined up and check a couple points to make sure that the data that goes together is together. So now that you have that data in, the next thing we're going to do is get out of this. So second mode, and then we're going to go second y equals, okay? We need to make sure that our plots are on, otherwise it won't plot our data. It's not going to show the dots on the graph. So we need to make sure that on is actually blinking. If it were over here and blinking on off, that's not good. So it needs to be on, you hit enter. Then the type we want, this is for the scatter plot right here. It does all kinds of different graphs, but we want this scatter plot. Okay, we are graphing list 1 and list 2, so L1, L2, and you can use any one of these little marks that you want. This one shows up really well, so I usually do use it. Okay, so now that I have that, I'm going to go to my windows. I need to set my maximum and my minimum. Okay, so this is looking at the scale that we're using. So when I look at this, 0 is the minimum. Okay, it's the smallest number I'm using for my X values, my inputs. So if I have 0, I could start there, or I could go a little bit below, and let's say I'm going to go with -2. So it's a little bit below, and for my maximum, I want to go a little bit above. Now, you also have to think about what are you going to count by. If I'm counting by 2s, the -2 is great. I might need to change this in a minute. My maximum is at 5, so I need to go a little above that. So let's say I go to 6. Well, that's going to work then. Don't do anything to this, okay? Leave it as is. It changes itself. Now for your scale. This is my X scale. If I'm going from -2, ranging from -2 to +6, I can count simply by ones because I don't have a whole lot going on there. If you wanted to spread it out more, you could count by halves, by 0.5. Now for my Y's. Okay, now I look at this set of data, and my smallest number is 55. My largest number is 100. So I have to go a little bit below that 55. So I'm going to go down to 50. And since my maximum is 100, I want to see everything in my window. So that's why I go a little below and a little above. So I'm going to go up to 105. Now, when you look at what's happening here, what should I count by? Well, this one ends in a 0, this one ends in a 5. I'm going to count by 5s because it's the simplest thing to count by. I don't want to count by 2s here because I end with an odd number. So that doesn't make sense, and my range is 55. I'm not going to count by 2s, my range is 55. So now that I have that information in there, I could actually check it to see what my graph is looking like. And I can see all my dots there. I know that it's working. So I am now going to go ahead and get the information I need for my diagnostics to be on and be able to get my correlation coefficient. So I am going to go second and program. Now that I'm here, I'm going to hold my down button down because see it goes alphabetically. I want diagnostics on. So I'm going to wait to see my D's, diagnostics on, and once it shows up on the screen, I do have to hit enter again. I have to see the word done. If I don't see the word done, it's not going to do what you want it to do. So now that I have that, I am going to go second list for stats. See how it says stats above it? That's why I hit the yellow button, because anything in yellow, you have to hit the yellow first before it'll work. I need to go over to calculate. Now, this is going to be a linear relationship, okay? That's all we've dealt with so far is linear relationships. So I need to go down to linear regression. There's all sorts of stuff in here, other things you're going to get to later, but number 5 is what you want. So you're going to hit enter, you're going to hit enter again. And lo and behold, look at what happens. We get an equation to show up. It shows us y equals ax plus b, where I go y equals, I take whatever it says y is. I don't have to write out all those decimal places. I know how to round. So negative 8.48 x, so we don't know what x is, that's the input, plus our b value, 94.64. Okay, so now that I know my equation, I'm also going to write down what the correlation coefficient is. It says, what is it? Okay, that correlation coefficient is not the r squared, it's the r. Remember we talked about that on the other side. So it's negative 0.929. Okay, so the closer it is to a 1, whether it's -1 or +1, the closer it's going, or the stronger the relationship is going to be. The further you get away from it, the weaker the relationship. So now that I have that information, I can go to y equals, and I can enter this equation in. So -8.48x, don't forget your x keys over here. Don't use times because that's not the same thing, plus 94.64. I hit enter. Now I can go to my graph and look at that. It shows me what the linear equation should look like and how well it's correlated. And the correlation has to do with how close are these dots to that line. The closer the dots are scattered to the line, the stronger the relationship. The more scattered out they are, the weaker the relationship. So that's really what correlation coefficient has to do with, and this is a great way to model it and see it. So when we look at the very end of this, correlation, which correlation represents the data above? Is it positive, is it negative, or is it no correlation? Well, when we look at this, it's going down the hill, so it is a negative correlation. And it's a pretty strong one because it's essentially like -93%. So when I look at this real world problem solving, we're going to look at this example here. It says the scatter plot shows the age and asking price for several used mid-sized cars. Which relationship does the scatter plot show? Well, as you can see, the line is going down the hill. As you increase here, you're decreasing with your price. So that one also is a nice little negative correlation. I hope this helps. Use this video as many times as you need to go through the steps in the process with the calculator. But now it's your turn. Go get them.